When developing serverless applications, going from the code on your machine to the cloud can seem daunting. Hi, I'm Katie, and in this demo, I'll walk you through myself deploying one of my applications to show you how you can debug, build, and deploy your next serverless application. We'll go beyond the first deployment as well, showing you how you can integrate parts of Google Cloud to help you in your iterative software development lifecycle. This is just one story, but hopefully through this demo, you'll be able to see the power of serverless. For the purposes of this demo, I have an application running locally on my machine. It's a small Python Flask app where you enter your name, a date, and a description, and it generates a certificate of attendance as an image. I've already pushed this code up onto GitHub, and now I want to deploy it to Cloud Run. Well, what is Cloud Run? Cloud Run is serverless for containerized applications. It allows you to develop and deploy highly scalable containerized applications on a fully managed serverless platform. Containers are one way to package your application. There are many ways that you can make containers, but for this demo, I'm going to let Cloud Run walk me through the process of containerizing this application. In the Google Cloud Console, I'll go and search for Cloud Run, and then once that's loaded, go and click Create Service. This will automatically enable the API that I need to be able to deploy to Cloud Run. I can then enter in my service name, award, I'll keep the default region, and then I get a choice. I can either deploy a revision from an existing container, or I can continuously deploy new revisions from a source repository. And that will use Cloud Build. Well, what is Cloud Build? Cloud Build is a continuous integration and delivery platform. It gives you complete control of designing custom workflows and allows you to deploy across multiple environments. I'll go into this sidebar, enable the APIs that I need, both the Cloud Build API and the Container Analysis API. And then I have a choice of which repos that I want to connect. You have a choice of connecting all your repos, or you can manage the connected repositories within GitHub itself. It'll ask me to log in, select my user, and then define exactly which repositories I want Cloud Build to have access to. Once I've set that up in GitHub, I can then select the repository that I've just added within the Cloud Build setup. From here, I have the choice of how I want to build my application. I can either build from a Docker file if I've defined it, or I can use Google Cloud Build Packs. Well, what are build packs? Build packs allow me to create an image without having to write a Docker file in a number of common programming languages and using common development tools for those languages. A 2019 study showed that 44% of containers scanned in the wild had known vulnerabilities or unpatched components. By using Cloud Build Packs, you can rely on security audited containers, allowing you to quickly use containers without worry. Build packs are used all throughout Google Cloud and are supported by many of its products, including, as we're seeing, Cloud Build. I'll select my build type, and I'll also open up the documentation for later. From here, I need to define my entry point. Now, for some programming languages, the entry point is default, but for Python, there is no default way to run your Python server. So I can and have to define an entry point here. I can either define it here in the configuration, or I can commit a specific file to my source control that will define that for me. For the purpose of this is what I'll do. I'll create a new file called a proc file or process file and tell it to, when I want to run the web service, I want to run gunicorn. gunicorn is a production-ready Python Whiskey web server, and using this means I don't have to use my development web server in production. This is a really useful thing to do. Now that my code has been committed, I can go back and complete the setup with Cloud Build and Cloud Run. For the purposes of this demo, I'll let the service be public, but you have control over the ingress and authentication before your service exists. And now, Cloud Run is creating the service. It'll set up IAM, create a placeholder version, create the Cloud Build trigger, and then run the deployment. These are the logs in Cloud Build that shows you the 3 steps that the build packs are going to do for you. It will run build pack build, which will build the container. It will then push the container, and then it will deploy the new service with that container. This is all being configured via the trigger that was automatically created, which says that for commits to my repository on the main branch, use the inline configuration that defines those 3 steps there. As the build pack system works, it detects that I'm using Python, uses a Python base image, installs my dependencies as per my requirements.txt, and then adds the custom entry point. And once that container is built, it pushes it up to Google Container Registry. Well, what is Google Container Registry? Well, it's a private registry for storing your containers. It's a place where you can store, manage, and secure your Docker container images. Now it's just a case of waiting for the deploy to complete, and we can check out the progress over on Cloud Run. And now we have a service? No. Well, that's not good. Well, let's have a look at what's actually going on here. It seems to be an error, but if I have a look at the placeholder, it shows me that something's gone wrong. This placeholder image is specifically designed so that if it's not overwritten by your service, it'll tell you something's gone wrong and give you some troubleshooting and debugging information. I can also go directly to cloud logging for my service. What is cloud logging? Well, it's just that, centralized logging. It allows for real-time log management and analytics at scale. So if I open up cloud logging, I can see I forgot to install GUnicorn. Well, I can go and fix that. Since I've already configured my repository to be integrated with Cloud Build, all I have to do is make changes to my repository, make a commit to the main branch, and those changes are automatically picked up by Cloud Build, and my deployment will rerun. The status button here in GitHub will automatically link you to the exact build that is running in Cloud Build. Now, if we just wait for this deployment to happen, the build is now successful. So if we go into Cloud Run and refresh this interface, we can see that the deployment has been successful. So now if I go and refresh my service URL, I can see my service is now up. This URL has been specifically created by Cloud Run automatically with HTTPS secured interface and is a combination of your service name, a hash of your project ID, and a short region code depending on which region you deployed to. So now my service is up, let's try it out. Enter in a name, use the defaults, and there's another error. But that's okay. Because I'm using a production-grade WSGI web server, debugging is disabled by default, which means that this is a good error because it's not displaying any debugging information to the user. For me as an administrator to see the debugging information, I need to go into the Cloud Run logs. They can be accessed by a tab right here in Cloud Run. And once those load, I can see just what's gone wrong. That's an error. Well, that's an error that I wouldn't want to normally see, but Cloud Run also has integration with error reporting. If you go to the Metrics tab, will automatically elevate any errors that it sees, which you can then go and click to see instances of that error. Well, what is error reporting? Error reporting is just that. It's application error reporting. It helps us identify and understand our application errors. So as I open error reporting, I can see that this error has occurred one time, 2 minutes ago, and I can see the stack trace. I can also choose to link to an issue. So for the purposes of this, let's copy out the error message and raise a bug over on our GitHub repo. I can create a new issue with as much information as I want, create an issue, and then copy that URL into error reporting and link it to this particular error. That way, if this error ever comes up again, it will be automatically tagged with a link to the issue that I've created for my own debugging purposes. Since I'm using build packs, the trigger was automatically created for me in this inline configuration. As part of the build packs documentation, it tells you how to extend your run image. This is what you would do to add extra system-level dependencies to your build. And to integrate that, you're going to need to edit that inline configuration to add that extra build step. For the purposes of this, such as with my proc file, I'm going to commit this to my repository as a cloudbuild.yaml, and then make the extra step and the changes required, including another run.docker file, as part of the build packs documentation. And then if I go back into my cloud build trigger and change it so that it uses the cloud build configuration from source control, I can use that changed configuration to add the system dependencies that I need for my particular application. I can also choose to manually run this trigger by specifying which branch and clicking the Run button on the Cloud Build Triggers listing. Once that deployment has been complete, I can go and refresh my server. And now it's at least come back. Let's see whether it's working. Did it work? It did work! I have now generated a certificate. This seems ready for production now. So if I go back into Cloud Run, I can change that default URL into a managed custom domain. I can either choose to add a mapping to a domain that already exists that I have control over, or I can register a new domain right here from the interface with help from the Cloud Domains API. I can search for a domain name. It'll tell me what's available globally, and with a click of a button, I can purchase it and it'll be added automatically to my cloud billing. A bit of DNS later, and my application is now in production. Now that my app is live, I can continue to develop my application, which is deployed anytime I make a commit to my main branch. At the moment, it's a minimum viable product, and I have some issues with it. For example, all those images are being stored within the running service. The moment my app restarts, I lose all the generated history. Cloud Run supports stateless HTTP containers, but I can use other Google Cloud components to store this state. I could host my images using cloud storage, taking advantage of multiple region support and multiple classes of storage. I could also use Firestore as a NoSQL storage for the award certificate information. Both of these components have client libraries that means that I can interact with these products with my preferred programming language. If my service gets to a stage where it requires credentials or other secure values, I can use Secret Manager to store my secret, and then update my service to reference that secret as either an environment variable or a mounted volume. Whichever functionality I need, there's a part of Google Cloud that can help me in a managed service. But as I'm developing these features, how can I make sure that my service keeps running? We saw a couple of issues as I was working through my demo. If a commit fails to build, it fails before the revision is deployed. If a revision fails to respond to health checks, the revision won't serve any traffic. But if the revision succeeds with its health checks, it will by default accept 100% of traffic served. The app will be running, but it may not be working. In the Cloud Run UI, you can manage the traffic of your different revisions, allowing you to do things like roll back versions of your app if something goes wrong. By using Cloud Run features and Cloud Builds automation, you can implement different rollout strategies depending on your use case and your deployment outcomes. Here are some possible examples of what you could set up. You could implement gradual rollouts, where the new revision of your service slowly takes on more traffic, giving you more time to confirm whether it's working as intended before it gets all user traffic. Check out the Cloud Run Release Manager repo on our GitHub for an example implementation. You could use the traffic splitting feature and tagged revisions features to configure deployment previews. As you're developing your application, when you create a pull request, a revision of the changes could be deployed, but configured to not accept any traffic. Instead, it's tagged with a revision URL unique to that pull request. You could use that to then check your changes against the running version of your application. Since it's a revision of the same service, it has all the same configurations, same database connections, environment variables, etc. It's just accessible by prepending a revision tag to the URL. This allows you to test your changes in near production parity. Check out the Configuring Deployment Previews tutorial on the Google Cloud documentation site for more information. You can also adjust your cloud build configuration to have additional verification steps before the build, push, and deploy steps. You could have cloud build run unit testing or linting checks against your code before you deploy. If these tests fail, the build will fail and your deployment won't proceed. You could set up that the GitHub repo only deploys to a staging service, and when you're ready to deploy to production, that could be a separate service in the same project or a completely separate project, allowing for separation of production data and staging data using Cloud IAM. Cloud IAM is resource access control, allowing for fine-grained access and visibility for centrally managed cloud resources. Through IAM, you can configure explicit access to resources built in your staging project to be accessible by your production project, or any other configuration that fits your architecture. When your app starts getting more traffic, you can start to see how your app behaves under load right from the Cloud Run console with Cloud Monitoring. Cloud Monitoring is infrastructure and application monitoring, allowing you to gain visibility into the performance, availability, and health of your applications and infrastructure. Through Cloud Monitoring, you can also set up alerting policies that adhere to your organization's SLOs with the option to send notifications to a number of different channels. Cloud Run services get to take advantage of many of the tools and processes that power cloud infrastructure. We've covered a lot of ways that Google Cloud can help you beyond your first launch, from troubleshooting tips, automation helpers, and context-aware integrations that can help you ensure you achieve the power of serverless. If you want to learn more about how serverless can help you build, run, and deploy, check out cloud.google.com/serverless. Thank you for watching. You've earned this. See you next time.